Welcome, everyone. Today we're diving into an absolute force of nature in the global economy. I am so excited to guide you through this explainer on the mind-boggling scale and the incredibly complex physical realities driving the 2026 semiconductor market. We are literally living through a modern gold rush right now. But, instead of pickaxes and riverbeds, we're dealing with atomic-level precision and multi-billion-dollar factories. We're going to see exactly how microscopic architecture is reshaping the wealth of the entire world. Okay, let's dive into this. We'll be looking at the trillion-dollar chip boom, the anatomy of a microchip, the picks and shovels, the foundry wars between TSMC and Intel, the US megafab resurgence, and finally, the capital dynamics.
All right, part one, the trillion-dollar chip boom.
To truly understand this industry, we first have to appreciate the sheer, unprecedented financial scale it has reached today. The AI boom has fundamentally rewired global market caps, creating titans of industry that just dwarf traditional economic powerhouses. Just listen to these staggering figures from May 2026. You've got NVIDIA leading the pack at an astronomical $5.2 trillion, followed by TSMC and Broadcom crossing that $2 trillion mark. Then there's Micron at just over $1 trillion, with AMD close behind. What you have to remember here is that this totally incomprehensible wealth is built entirely on microscopic architecture. These valuations are pricing in the future of artificial intelligence, cloud computing, global infrastructure, all of which depend entirely on our ability to print smaller and smaller circuits onto pieces of silicon. But to support those trillion-dollar valuations, you need an equally mind-blowing physical footprint. $165 billion. That's not a typo. That is TSMC's planned investment for their Arizona site alone. They recently expanded their plan from 3 to 6 fabs, including advanced packaging lines and a whole R&D center. It just beautifully illustrates the sheer physical and financial weight required to keep this tech boom going. You can't just code your way to AI dominance. You have to pour hundreds of billions of dollars into concrete, steel, and clean rooms first.
Moving on to Section 2, Anatomy of a Microchip.
So what exactly are they building inside these $100 billion factories? Well, let's take off our investor hats for a second, put on our lab coats, and decode the actual science. The manufacturing magic happening inside these fabs is easily the most complex engineering feat in human history. Making a microchip is this journey of extreme precision. It starts with wafer production, where we take purified silicon and slice it into perfectly smooth disks. Then comes photolithography. This is where we use light to project incredibly intricate circuit patterns onto a light-sensitive coating. Next up is etching, which actually removes material to carve out those patterns. Then doping, shooting ions into the silicon to change how it conducts electricity. Next, deposition adds microscopic layers of new materials. And finally, testing and packaging to make sure the whole shebang actually works. Walking through these 6 steps, you really start to realize why creating these chips is so incredibly difficult and expensive. I mean, you're practically playing God with individual atoms.
Section 3, the picks and shovels.
Let's see how this science builds into our next concept, the companies that make this impossible engineering possible. During a gold rush, right, it's often the folks selling the picks and shovels who make the most reliable fortunes. While companies like NVIDIA and AMD are out there finding the gold, the equipment makers are selling the highly specialized, completely unreplicable shovels. And the ultimate shovel in today's market is EUV, or extreme ultraviolet lithography. This is an advanced manufacturing tech that uses light with an extremely short wavelength to draw the absolute smallest possible transistors. If you want to make chips at the 5nm or 3nm scale, the exact chips driving the AI revolution, by the way, EUV is the absolute non-negotiable gateway. You literally cannot play in the modern AI arena without it. And this brilliantly illustrates a fascinating, kind of wild market reality. ASML is the only company on the face of the earth that can manufacture these EUV machines. Nobody else can do it. They hold an absolute global monopoly on a bottleneck technology that the entire modern world relies upon. It's really no wonder they command such a massive premium in the market, right? Without ASML's machines, those trillion-dollar valuations of the chip designers we talked about earlier, they'd simply evaporate. But hey, it's not just lithography. Take KLA Corporation, for example. They hold the #1 market position in 7 out of 10 process control subsegments. As these transistors shrink down to the 2nm level, the risk of some microscopic defect destroying a hugely expensive AI chip skyrockets. Metrology and inspection are no longer just nice to have, they are structural necessities. Chip makers have virtually no choice but to buy KLA's high-margin services just to ensure their multi-billion-dollar fab runs actually produce working chips.
All right, Section 4, Foundry Wars, TSMC versus Intel.
Now that we understand the tools, let's shift over to the intense corporate battlefield where the titans who actually fabricate the chips are fighting for absolute supremacy. The foundry wars are really heating up, and the stakes have never been higher. So the crucial point here is the massive, character-driven turnaround currently underway at Intel. Following Pat Gelsinger's tenure, where Intel sadly saw its data center server share slide, Lip-Bu Tan took over as CEO in 2025. And he hasn't minced words about the past. He recognized that previous reporting structures left the engineers totally disconnected from leadership. His immediate fix? Having every single engineer report directly to him. It's a dramatic, incredibly hands-on restructuring aimed at salvaging Intel's roadmap and getting their crown back.
This creates a really stark contrast in the industry right now. On one hand, you have TSMC's established, totally dominant pure-play foundry model. They don't design chips to compete with their customers, they just flawlessly manufacture them. On the other hand, you have Intel, currently engaged in this desperate internal restructuring to flatten silos and execute perfectly on their upcoming 18A and 14A nodes. Intel is racing against the clock to prove their turnaround is real, so they can finally attract those same external customers that TSMC currently dominates.
Which brings us to Section 5, the U.S. megafab resurgence.
While TSMC and Intel battle it out globally, there is a massive geopolitical shift happening at the exact same time. Recognizing the huge vulnerability of global supply chains, there's this aggressive push to bring massive semiconductor fabrication back to American soil. Driven heavily by CHIPS Act funding and deep national security priorities, the U.S. is seeing just historic infrastructure projects. We mentioned TSMC's expanding Arizona Hollow Vista site earlier, but you also have Micron, who officially broke ground on an unprecedented $100 billion megafab in upstate New York to secure leading-edge memory manufacturing. Meanwhile, GlobalFoundries is executing massive expansions in New York and Vermont, focusing on critical automotive, IoT, and quantum tech. The physical landscape of American manufacturing is literally being redrawn right before our eyes.
And finally, Section 6, the capital dynamics.
Okay, let's tie all of this together. The microscopic science, the picks and shovels, the massive megafabs. Let's bring it back to the financial markets. What is institutional money doing with all this information right now? Well, the appetite is absolutely voracious. The global wafer fabrication equipment market outlook for 2026 has been revised upwards multiple times in just a few months. Early estimates were sitting around the low $130 billions, but current estimates have crossed well above the $140 billion mark. Why? Because everybody wants their manufacturing tools sooner. The urgency to build AI infrastructure is accelerating capital expenditure at a truly breathtaking pace.
Now, what's really interesting here is the downstream effect of all that urgency. Equipment providers like Applied Materials and KLA are reporting something incredibly rare: unprecedented visibility into the next year. Customers are locking in delivery slots for factories that won't even open until 2027. We're talking huge backlogs extending for years. This gives these equipment companies a remarkably stable, predictable runway of revenue, partially insulated from those near-term chip demand fluctuations.
Which leaves us with a fascinating question to ponder. We know market cycles exist, right? The current AI hypergrowth will eventually normalize. So, when that gold rush inevitably slows down, will the fabless chip designers maintain their trillion-dollar valuations? Or will the companies that built the ultimate picks and shovels, the ASMLs, the KLAs, the Applied Materials, with their long-term service contracts and multi-year backlogs, be the only ones left holding the real, durable treasure? It's something every focused learner and investor absolutely needs to keep their eye on. Thank you so much for joining me on this explainer. I really hope you walk away seeing the microscopic world in a whole new multi-billion-dollar light.